Hi everyone, welcome to how to use properties of logarithms. In this video we're going to go through 12 examples using all the properties that we talked about in the last video. So first examples here from my pen. So this says use the fact that log of 2 is 0.3010, log of 5 is 0.6990, and log of 7 is 0.8. Move myself lower. Log of 7 is 0.851 to evaluate each logarithm without a calculator. Okay, so the goal here is to break these guys up into one of these three numbers, and then using this, try to figure out these guys. So 35, how can I split 35? Well, 35 I know is 5 times 7, so I can split this into 5 times 7, and I can use product rule. So the product rule says I split it into the sum. So this would be log of 5 plus log of 7. Log of 5, as we know, is 0.6990. Log of 7 is 0.8451. So all I would do is I would add these guys together, and that would give me my log of 35. And I'm going to go quite quickly through these because we have a lot of examples to cover. So we add those together, those would be a total, and that would give us log of 35. Alright, log of square root of 5. Well, we know log of 5, but we don't know log of square root of 5, so how can I use my rules to make this into something I know? Well, square roots I know as an exponent, or the 1/2 exponent. Now I can use the power rule to drop that down in front. So this is really 1/2 log of 5, and then I can use the fact that log of 5 is equal to 0.6990, and then all I have to do, compute that, and we'll be done there. Alright, what of log of 8? Well, we don't have an 8, so we have 7, 5, and 2. How could we do log of 8? Well, is there a way that I could make an 8 of using only 2's? Well, yes, I can. If I think and remember that log of 8 is really 2 cubed, and then I can drop that 3 down in front. So 3 log of 2. And then I know if log of 2 is 0.3010. Calculate that out there, and then we would be done. So I like these because they're like puzzles, so you have to figure out how to split these guys into the 3 known numbers. So that's one way to use our log properties. So here's example 2 of 4. Oh, too much. 2 of 4. Use properties of logs to simplify each expression by eliminating all exponents and radicals. Okay. First guy, well, I can't use power rule because the 3 isn't out here, it's inside, so I have to split the product first. So I can split the product into a sum, log of y to the 3rd, and then I can use power rule, log of x plus that 3 can come down in front. 3 log, my g's and my y's look the same, so I'll put that in parentheses. So we're done there. We split it, got rid of all exponents. Okay, what about this guy? So you're really going to need to tap into your fractional exponents for these. So I'm going to change these radicals into fractional exponents. So a cubed root is to the 1/3 power. The 4th root is to the 1/4 power. Alright, this is a product. Let's split it. So log of x to the 1/3 plus log of y to the 1/4. Then power rule. Exponents drop down in front. And then this will be 1/4 log of y. Done. We split it, no more exponents. Okay, what about this guy? So we have to split the quotient. Quotients split into differences. So it's always numerator minus denominator. So this would be log. I'm also going to change the root into a fractional exponent. So the cubed root is the 1/3 power minus the denominator, the log of y squared. Okay, invoke power rule again. 1/3 log of x minus 2 log of y. So that 2 drop down in front and that 1/3 drop down in front, which we can do because power rule said we can. Alright, example 3. So this is another type. Write each logarithm as a sum or difference of logarithmic expressions. Eliminate exponents and radicals and evaluate logarithms whenever possible. So we need to not only split it, but now we also need to get rid of all the exponents. So anytime you see a quotient, think subtraction. So this would be log of numerator minus log of denominator. Okay, I'm going to split this again because these guys are a product. Products splits into sums. Log of y to the fifth minus, what is log of 10? Remember, log when we don't see a base is log of base 10. So 10 to what power equals 10? Oh, 10 to the first power equals 10. So log of 10 is 1. Invoke power rule. So 2 comes down in front plus power rule. So 5 comes down in front. 5 log x log y minus 1. That guy's done. Okay, we're going to do the same thing here with ln and e. So we're going to split this guy first. So again, quotients split into differences, and then I'm also going to change the radical to a fractional exponent. So the cube root of something squared is just the 2/3 power minus ln of e squared. Okay, let's invoke power rule. 2/3 ln of x minus 2 ln of e. Oh, what happens with ln of e? They're inverses of each other, so they cancel out. So this will just end up being 2/3 ln of x minus 2. And we're done here. Okay, next, let me move my pen somewhere else. Maybe not in the middle of the problem that we've just done. There we go. That's a good spot there. All right, this is log base a, so the base matters. So this first thing, let's split this quotient into subtraction. So log base a of, and I'm going to make this a fraction again, plus y square roots are to the 1/2 power, minus log base a of a cubed. Okay, then I'm going to invoke power rule, and 1/2 is going to come down here in front. 1/2 log a to the x squared plus y in here. And minus, okay, a to the what power is a to the third. So a to what power is a to the third? So log base a of a cubed, this is simply going to be 3, because the log base a of a cancels each other out, and we're just left with the 3. Okay, and we split that guy, so that guy is going to be taken care of as well. All right, the last ones. Let me move, maybe right here is a good place for that pen. Okay, in this last example, write each expression as a logarithm of a single number or expression. So these guys are expanded, and what we want to do is we want to compress them. We want to put them all together. So we're going to kind of go backwards of the way that the rules are traditionally written. The rules are kind of written to like blow them up or expand them. We're going to now take them expanded and put them all back together. We're going to crush them. Okay, so ln of y minus ln of 2, this is a difference. The difference is turned into quotients. So this will be ln of y over 2 plus ln of root x. We don't have to do anything with the exponents in this case. All right, sums turn into products. So this will be ln of y over 2 times square root of x. So that'll simplify into y square root of x over 2, because this guy's really over 1. Multiply across, multiply across. So we get ln of y root x over 2. So that is a single logarithm, so our job is done here. Let's put these guys together now as a single logarithm. So we're subtracting, which in our properties turns into division. So it's always the first over the second. Okay, now can we simplify this? Yes, we can, because it factors. X squared minus 9 is x plus 3, x minus 3 over x plus 3. Hey, those guys will cancel. So this whole thing is actually just going to turn into ln of x minus 3. And we're done. Last one, and this is like the challenge problem of the whole thing. Okay, we need to turn this guy into a single log. I'm going to invoke some rules of exponents first though, and power rule. So let me do power rule first. So I'm going to take that 3/2 and I'm going to put it up here, and I'm going to take that 1/2 and I'm going to put it back on the exponents because we can do that. And then I'm going to invoke rules of exponents, where it says that this exponent gets to distribute to everything inside the parentheses via multiplication. That's power rule of exponents. So I'm going to do that. So 16 to the 3/2 power. Well, the 1/2 power of 16 is 4, because that says take the square root and then raise it to the 3rd power. So this would be log. So the 3/2 root of 16, we'll take the square root first, that's 4, and then raise it to the 3rd power. So that'll be 64. And then x to the 4th times 3/2, so 4 times 3/2, this will be 12 over 2, which is better known as 6. Minus log y to the 8th. 8 times 1/2 is 4, so this will be end of y to the 4th in here. Okay, and then we want to put this as a single logarithm. So we're going to, this is a subtraction, which is going to turn into a quotient. So this will be 64x to the 6th over y to the 4th. And now we've done our job because we've written the expression as a single logarithm, and we've simplified everything that we can simplify. Nothing else is going to simplify in here. So done, done, and done. So that was just a couple ways to use the properties of logs. So we saw 4 different examples of that, and these are just some creative ways to use the properties, but they can be used literally any way you need to use them. They're just there to make your life easier, and we'll see how to use them again when we go to solve logarithm equations. We'll see how they work to our advantage to make our problem easier, which is again what the properties are there for. How can I make my life easier? So I hope that helped. If you have any questions, please just ask, and I'll see you guys in the next video.